basically what they are counting numbers. Well, very good. Now, after natural number is a set. Okay, it is a set. It is a collection of some entities. Now, after natural numbers, if zero is added to the set of natural numbers, then what it becomes? It becomes whole numbers. Okay. Okay. So in whole numbers, what is there? Whole numbers are similar to natural numbers but include zero. After that, we come to the set of integers. So here you can see I have written your natural numbers, and after natural numbers, I have denoted it by capital N because its starting is from N natural numbers. So I have put it N over there. In whole numbers, I have put W, and in integers, I have written here Z. So why I have written here Z, can you tell me? No idea. Don't worry, I'm here to tell you. Because the Z word has been taken from German word that is zählen, that means to count. Okay. Okay. So here what we are doing, we are considering the negative numbers also, positive numbers also, and in between zero also. Means in the set of whole numbers, we are adding the set of negative numbers also. Then we get the set of integers. Okay. Got it? Okay. Very good. Now moving forward. Another type of number, that is rational numbers. Okay, so again here it is denoted by Q, but it is starting from R. So why Q is there? Can you tell me? Any guess? Don't worry, I'm here to tell you. So it is about quotient. Okay. Okay. So quotient is what? Quotient is means division or fraction and all that. Got it? So here we are just forming the numbers that are of the form P by Q, where Q should not be equal to 0 and P and Q are integers. That's why we are denoting it by Q. Okay, got it, Yash? Okay. Yes, ask me. Okay, I got it. So you are asking me, then we have studied fractions also, but why we are studying rational numbers? Okay. Because in the fraction part, you were studying the form of P by Q, but there you were studying in P by Q form, they were whole numbers. But here in the P by Q form, they are integers. This is the difference between fractions and rational numbers. Okay. In your previous classes, in your earlier classes, you have studied about fractions, right? There you have added them, subtracted them, multiplied them, and divided them. The same concept you will study here also, but the difference is you were just basically studying the p by q form in the form of whole numbers where q was not equal to 0. But here you will be doing all the things with integers. Got it? Got the difference between fractions and rational numbers? Great. Now come to the next one, that is real numbers. But before real numbers, there are rational numbers, and those numbers that cannot be represented in the form of p by q, where q is not equal to 0, then they are irrational numbers. Got it? Irrational numbers, yes. Like if you want to find the value of root 2, root 5, okay, root 7, these are all irrational numbers. But if I ask you if root 4 is an irrational number or not, yes, it is not an irrational number because the value of root 4 is equal to 2. That's why. Good. Yes, and pi also. If we write pi, that is 22 by 7, then it is also an irrational number. Got it? Yes, but there is a little bit yes, yes, I got it. Good. Yes, when you divide 22 by 7, that you are not getting an irrational number, but actually pi is an irrational number. Okay, because experimentally, when we divide the circumference, that is circumference of a circle, the boundary of the circle. Yes, that formula is 2 pi r. So when we are dividing 2 pi r by diameter, then we get r. That is 2 pi r divided by 2d, we get the 2r, then we get the value of pi. That is 3.14, so on up to. Okay. So here, the value of pi is an irrational number. Okay. So pi is an irrational number. Got it? For making our calculations easier, we just take it 22 by 7. But actually, it is 3.14 dot 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 dot. It is non-terminating, non-repeating decimal expansion. Got it? And when there is non-terminating, non-repeating decimal expansion, then it is an irrational number. Understood? Very good. Now we come to the set of real numbers. So real numbers are denoted here by capital. Now real number include both rational and irrational numbers. Okay, because in rational numbers, we are studying all the numbers under it. Because natural numbers are also rational numbers, integers are also rational numbers, whole numbers are also rational numbers. So in rational numbers, we are encompassing all other number systems also. So rational numbers plus irrational numbers, we are getting the whole bunch as real numbers. So up till 9th and 10th class, you will be doing your all calculations and all your study regarding the real numbers only. Okay, good. So moving next. This is about the complex numbers. Okay. So this, I should tell you this because it will be helpful in your higher classes, but you should have an idea about the complex numbers because you should know that there is no boundary up to real numbers. You will also be studying another set of numbers also. So that is complex numbers. Okay, where we are also discussing about the imaginary part. Like if we are studying the real number. So real numbers, for that we are doing the Cartesian plane, but for the complex numbers, we will go to another one, that is imaginary part is also added there. So it is in the form of a plus bi, where I is equal to square root of -1. Do you know you can find in 8th class, in your earlier class, you have studied about the square roots. You can find the square root of root 4, that a perfect square. Okay, you have studied about the perfect square and which are non-perfect square, but have you studied about the square root of negative numbers? No. So that comes under complex numbers. Okay, got it. So here it is the you can see here the complex numbers are mathematical entities of the form a plus bi, where a and b are real numbers, and I represents the imaginary unit square root, that is under root of -1. Okay, so you will get better idea by seeing this Venn diagram. Okay, so here in this Venn diagram, can you see here? The set of real numbers is the biggest set, under which comes the rational and the irrational. In the rational one, there comes integers. Within integers come the whole numbers, and within whole numbers come the natural number. And in irrational numbers, it is another set that is not covering other numbers because it is separate set that is having non-terminating, non-repeating decimal expansion. Got it? Like here in the rational section, you can see 0.3333 dot dot dot. So here the decimal expansion is repeating but non-terminating. So it is rational. But here in the irrational, it is non-terminating and that's why it is irrational. Because here in the irrational section, you can see -1.450973256 dot dot. So it is non-terminating and non-repeating. That's why it is an irrational number. Got it? Any doubt up till here? Okay, good. So moving next, this is operations on real numbers. So you know what are mathematical operations? Yes, basically there are 4 mathematical operations: addition, subtraction, multiplication, and division. Very good. Very good. So in the real numbers, when you are studying operations on real numbers, so there these 3 important things you should know very well. First, the addition or subtraction of a rational number with an irrational number always leads to an irrational number. Got it? You can, okay, I'm just taking an example by which it will become easier for you to understand. Consider irrational number to be a disease, communicable disease. Okay. Okay. Just consider it. You will get to know about it. You will, when you will do the question, then it will come to your mind, and you will possibly mark them irrational or rational depending upon this notion that I'm just telling you. So consider irrational number to be a communicable digit. So when whoever attaches to it, it makes it a rational number. Okay. So if we are adding or subtracting a rational number with an irrational number, we will eventually get what? Irrational number. Got it? Same way, if we are doing the product or division of a non-zero rational number and an irrational number, then it always leads to an irrational number. Got it? Okay. The third point is very much important. It says that when we are taking two irrational numbers and when we are adding them, subtracting, multiplying, dividing, it is not always you will get an irrational number. You will be getting either rational or an irrational number. Got it? Okay. Why? Okay. Let me tell you an example. Like if you are taking 3 plus root 3, so it is an irrational number. Yes or no? Yes, because in the first point you have studied that addition of a rational number with an irrational number always leads to an irrational number. So when we are adding 3 plus root 3 to root 3, 3 is an rational number, 3 is a rational number, and root 3 is an irrational number. So 3 plus root 3 is what? It is an irrational number. But when I'm subtracting minus root 3, when I'm subtracting root 3 from it, root 3 is an irrational number. So 3 plus root 3 minus root 3, it will give us 3. That is a rational number. So it is not always the case that when we are adding, subtracting, multiplying, or dividing two irrational numbers, we will be getting irrational. We will also be getting a rational number or an irrational number. Is it clear to you, Yash? Any confusion up till here?